Hello everyone, myself Assistant Professor Vatsal D. Patel from Civil Engineering Department working at Mahatma Gandhi Institute of Technical Education and Research Center NAVSARI. Today we are going to discuss about theory of errors and our today's topic is types of errors and definitions. So be ready with your pen and paper. So let's start with the introduction first. Measurement of distances and angles are made in various surveying operations. These survey measurements may involve several elementary operations such as setting up, centering, leveling, bisecting, and reading. In performing these operations, it is impossible to determine the true values of these quantities or say distance or angles because some error always creep in all measurements. So the errors occur due to imperfect instruments, human limitations, and climatic conditions or due to carelessness. Hence, the survey measurement always contains some errors. This necessitates a proper control, assessment, and distribution of errors. As far as possible, errors should be minimized while taking the measurements by adopting standard procedures and methods. The errors which still creep in survey measurements should be eliminated or their effects should be corrected. So let's see the types of errors. So the errors can be broadly classified into three types. First one is gross error or we can say mistakes. Second one is systematic or cumulative errors, and third one is accidental or random errors. So this theory is important for your examination, so be sure you remember it very well. So let us discuss it in detail. So let us see first one, the gross errors or say mistakes. So the errors which arise from carelessness, inattention, and poor judgment or confusion in the mind of the inexperienced surveyor are termed as mistakes. For example, if a surveyor or we can say observer reads the horizontal circle of a theodolite 131 degree for 129 degree, it is mistake. If a mistake is undetected, it produces a serious effect on the final result. Mistakes are quite random both in occurrence and magnitude. To eliminate such mistakes, observer has to be very alert while making observations. By careful observation and by adopting standard procedures and methods, the mistakes can be avoided. Suitable check measurements should be taken to detect the mistake at the regular intervals. Next is systematic or say cumulative errors. The errors which always follow some definite mathematical or physical laws are termed as systematic errors. Under the same conditions, the systematic errors are of the same sign and magnitude. Systematic errors are errors caused by factors that can be accounted for and suitable corrections applied to the observed values. For example, the error in the length of the steel tape due to change in temperature during field measurement is a systematic error. It follows the physical law of expansion of solids. The error can be computed and a suitable correction applied to the measured length of the steel tape. Systematic errors either make the result too great or too small, and accordingly these are regarded as positive or negative. As their effect is cumulative, these errors are also known as cumulative errors. Examples of systematic errors are the error due to sag of a tape supported at its end, wrong length of a chain, atmospheric retraction, etc. So if we talk about solution of systematic errors are very serious. So they must be detected. To eliminate these errors, all the surveying instruments should be so designed and used that as far as possible, systematic errors are automatically eliminated. For example, most of the systematic errors in measurement of angles with a vernier theodolite can be eliminated by taking both phase readings like phase left and phase right. Systematic errors that cannot be surely eliminated must be evaluated and a suitable correction should be applied. For example, the error due to temperature changes in the measurement of a length with a steel tape is computed and suitable corrections are applied. Next is accidental or random errors. So the errors which remain even after eliminating mistakes and systematic errors and are caused by a combination of various reasons beyond the control of the observers are termed as accidental errors. They do not follow any specific laws and may be positive or negative. Accidental errors follows the law of probability. These errors sometimes increase the result and sometimes decrease the result. As accidental errors tend to compensate each other, these are also referred to as compensating errors. So, accidental errors occur due to lack of perfection in the human eye. For example, while measuring a distance with a steel tape marked in centimeters, if one has to estimate the distance in millimeters, he may estimate a distance of 10 mm as 9 mm or 11 mm because the eye cannot judge the exact division. Okay, so I cannot judge the exact division. This would cause an accidental error. Erroneous calibration of a chain is also an example of an accidental error. Random errors are generally small and never be avoided in observations. The smaller the random errors, the better the precision of the measurement. Thus, accidental errors represent the limit of precision in the determination of a value of length or an angle. Next, we are going to see various definitions. So, the following definition of some of the terms should be clearly understood in adjustment of the measurement. So, let's see. So, first one is observation. Second is observed value of a quantity. Third one is true value of a quantity. Next is true error. Then most probable value, or it is denoted by MPV. Next, most probable error. Next is residual error. Then observation equation and conditioned equation, and lastly normal equation. So these these all definitions are very important for your examination. So we are going to see it in detail. So be ready for it and be sure you remember each and every definition because it is very important for your examination. So let's start with the observation first. So the measured numerical value of a quantity is known as observation. For example, 15.36 meter, or we can say 45 degree, 20 minute, 15 second, etc. So the observation may be classified into two types: direct observations and indirect observations. So if we talk about direct observations, An observation is called a direct observation if the value of a quantity is measured directly. For example, measurement of an angle, for example 45 degree 20 minute 15 second with a theodolite, it is a direct observation. The distance between 2 points is measured as 18.53 meter with a tape in the field. It is also a direct observation. Now, if we talk about indirect observation, an observation is called an indirect observation when the value of the quantity is calculated indirectly from the direct observations of the other quantities. For example, the value of the angle at the main triangulation station computed from the measured angle at the satellite station. When an angle is measured by repetition, the observed value of the quantity is indirectly derived from a number of observations. Next is observed value of a quantity. The observed value of a quantity is the value obtained from the observation after applying corrections for systematic errors and eliminating mistakes. The observed values contain random or accidental errors. So the observed value of a quantity may be classified as independent quantity, and second one is conditioned quantity, or we can say dependent quantity. So if we talk about independent quantity, if the value of an observed quantity is independent of the values of other quantities, it is known as independent quantity. An independent quantity does not have any relation, or we can say condition, with the other quantities, and hence change in the other quantities does not affect the value of this quantity. For example, reduced level of a benchmark is an independent quantity. Now if we talk about dependent or conditioned quantity, if the value of an observed quantity is dependent upon the values of other quantities, it is known as a dependent or conditioned quantity. For example, the angles A, B and C in a plane triangle are conditioned quantities since they are related by the condition equation A plus B plus C is equal to 180 degree. In this condition equation, any two angles may be regarded as independent and the third as dependent or conditions. For example, C is equal to 180 degree minus into bracket A plus B bracket over. So this is about the observed value of a quantity. Next is true value of a quantity. The value of a quantity which is free from all the errors is known as the true value of quantity. Because it is not possible to eliminate all the errors completely from a measured quantity, the true value cannot be found. It is a hypothetical quantity. Next is true error. The difference between the true value and the observed value is known as true errors. So true error is given by the equation true error is equal to true value minus observed value. So as the true value of a quantity is never known, the true error cannot be determined. Next is most probable value, or it is denoted by MPV. So the most probable value of a quantity is the value which has more chances of being true than any other value. The most probable value is therefore a value which is very close to the true value. This value is derived from several measurements of the quantity. Next is most probable error. It may be defined as the quantity which is subtracted from or added to the most probable value of a quantity. It fixes the bounded limits within which the true value of the observed quantity must lie. Next is residual error. The difference between the observed value of a quantity and its most probable value is called the residual error. Residual or variation thus is given by the equation residual error is equal to observed value minus most probable value. Next is observation equation. An observation equation is the relation between the observed quantity and its numerical value. For example, A plus B is equal to 78 degree 15 minute 20 second is an observation equation for the angles A and B. Next is condition equation. Condition equation is the equation expressing the relation between several dependent quantities. For example, in a triangle ABC, A plus B plus C is equal to 180 degree is a condition equation. And the last one is normal equation. A normal equation is the one which is formed by multiplying each equation by the coefficient of the unknown whose normal equation is to be found and by adding the equations thus formed. The number of normal equations is the same as the number of unknowns. The most probable values of the unknowns are found out by using these normal equations. So here are the important questions which can be asked in your examination, and we have already seen these two in detail. So be sure you remember these two theories very well because it is very important for your examination. So here I end my session. Thank you all of you.